This is part 2 on our discussion about the VSEPR theory. So here we have CS2. Let's draw the electron density structure of CS2. We have one carbon. Carbon will be the central atom. Then we have here two sulfur on the sides of the central atom. Next, sulfur, it has 6 valence electrons. Carbon apat, then sulfur 6 valence electrons. On this case, sulfur has 6 valence electrons. It needs 2 more valence electrons to be stable. So it will reach out to carbon to get that 2 valence electrons. So it will form a double bond with the carbon over here. The same thing for sulfur. Here it has 6 valence electrons. It needs 2 more valence electrons to be stable, and it gets that from the carbon in the center. So it will form also a double bond with the carbon in the center. Next, let's place the remaining valence electrons on this dot structure. Again, sulfur, it has 6 valence electrons. Again, on this case, we have here at the end of this line here, this is composed of two atoms from, valence electrons from two atoms that is shared between the atoms. In this case, sulfur has 6 valence electrons. We already have 2 here, 1, 2. Let's place the remaining 4. 1, 2, 3, 4, 5, 6. Again, that's 1, 2, 3, 4, 5, 6 valence electrons. Then, on this case, the same thing for sulfur here. Dalawang valence electrons already in this model. Again, we must put 6 dots over here. 1, 2, 3, 4, 5, 6. Then for carbon, that's apat na valence electrons. 1, 2, 3, 4. This is now the electron dot structure for CS2. Again, we can simplify the structure by removing the valence electrons around the atoms on the sides of the molecule. So this is the simplified electron density structure for CS2. Again, this is the 2D shape. This is the 2D model of CS2. But again, we have the 3D shapes of the molecule. Again, the 3D shape is the VSEPR shape of the molecule. On this case, again, we just count the number of electron groups. So electron groups are the areas occupied by electrons around the central atom. In this case, let's count how many electron groups. There is one over here and then another over here. So overall, we have dalawang electron groups. So in this case, we have 2 electron groups here. The next, let's also count the number of lone pairs over here. So how many lone pairs here? So in this case, walang lone pairs around the central atom. In this case, we have 0 lone pair. Then again, we just look for these details on the graph or on the table over here. Again, that's 2 electron groups and we have 0 lone pair. The shape here is linear. Again, just copy this format here. Again, here we have CS2. Again, that's CS2. On this case, again, that's on this case the center, that is carbon. Then here we have dalawang sulfur on the sides. Then just right here the shape here is linear. Okay, that's the shape of this molecule. So let's try to visualize this using this one. Let's try to use the simulation here. So it's over here. Again, let's draw the molecule we have here. Again, that's we have isa, then we have dalawang atoms on the sides. This is the shape for that molecule. Again, this one is linear. Again, this one is carbon, then this is the 2 sulfurs on this molecule. Again, if you try to move this one, the other one moves because again, this 2 electron groups here, this bonds here, again, these are negative, and again, they tend to repel away from each other. So that's the model of this molecule. Let's go to the next one. The next molecule here is, okay, wait for a while. Okay, okay, let's go to the next slide. So let's have CH4. On this case, we have carbon, carbon on the center, then apat na hydrogen on the sides. To be organized, let's put one hydrogen per side of the molecule. So in this case, again, hydrogen, it has 1 valence electrons. It needs 1 more valence electron to be stable, and it gets that one from the carbon. The same thing here, 1 valence electrons. one valence electron, it needs more one valence electron. It reach out to the carbon from the center. The same thing here, one valence electron. It needs one more single bond, one valence electron. It needs one more. It reach out to the carbon in the center here. Next, let's check the number of valence electrons, the number of dots in our electron dot structure. Again, for hydrogen, that's one valence electron, that's one, 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 one. Then for carbon, that's apat na valence electrons, that's one, two, three, four. So this one is the electron dot structure for CH4. Again, this is the 2D shape of the molecule. This is the electron dot structure, electron dot structure, electron dot structure of the molecule. Again, let's get the VSEPR shape. The VSEPR shape is again the 3D shape of the molecule. So in this case, again, we count the number of electron groups, count the number of electron groups, then count the number of lone pairs. In this case, how many electron groups? Just count the number of areas occupied by the electrons. We have it here, 1, 2, 3, then 4. On this case, we have apat na electron groups. Then on this case, we don't have any lone pair. That's 0 lone pair. Then for this, check the table. On this case, we have 4 electron groups. Then we have 0 lone pair. The shape for this molecule is tetrahedral. On this case, again, copy the format here. Again, this one is CH4. The central atom will be carbon. Then we have apat na hydrogen. So in this case, we have this wedge line over here. So just copy this one first, this wedge line. Then the other one is the broken line. Then here we have H. Okay, let's see this in the actual model for this molecule. Okay, let's look it here. Again, we have apat na the atoms around this one. So how do we draw this one? Okay, as you see here, uh, again, this one is, we have carbon here, carbon, and again this one is hydrogen dito, then this one is also on the plane. So as you see, this bond is coming forward. So to draw this one, you use a wedge line. Again, this wedge line meaning this is coming out to you. So if we go back here again, okay, on this case, diba, this bond is coming forward. So again, we use a wedge line to draw this one. Over here, the next, this bond is going backward. So here you use a broken line for this one. So that's how you draw this one. Again, this simple line means it's on the plane of the paper. Then this one is coming forward. And to draw this one, you use a wedge line. This bond is going backward. So you, on this case, you use a broken line. That's the shape of CH4. Again, the shape of this is tetrahedral. Again, that's tetrahedral. Next, let's go to the next one. We have, sorry. Okay, let's have the next one. Let's have NH3 here. In this case, again, draw the electron dot structure first. We have nitrogen, then we have tatlong hydrogens here, tatlong hydrogens. Again, hydrogen, one valence electron. It needs one more. It will form a single bond with a central atom. The same thing here, one valence electrons, kulangan ng isa, it will form a single bond here. Isa ka valence electrons, it will form a single bond with the central atom over here. Next, count the number of valence electrons here. Hydrogen 1, that's good. One valence electron, one valence electrons. For nitrogen, it must have 5 covalence electrons. We already have 1, 2, 3 here. We need 2 more. Again, that's 5 valence electrons. This is now the electron dot structure for NH3. Again, this is the electron dot structure, electron dot structure. Next, let's draw the structure. Let's draw the VSEPR shape of the molecule. On this case, again, you first count the number of electron groups, electron groups. On this case, again, we have it here, isa, duha, tulo, 1, 2, 3, then 4. On this case, we have 4 electron groups. Then, do we have any lone pairs here? We have, right? So here we have one lone pair. Again, look for this info in the table. and that's over here. So again, we have 4 electron groups, then we have 1 lone pair. The shape for this one is trigonal pyramidal. Okay, that's trigonal pyramidal. And again, copy this format over here. We have nitrogen in the center, then line over here. This one is H. Then this one we have the wedge. Again, this means this bond is coming forward, coming forward. Then this bond is the broken line. We use a broken line to emphasize this bond is going backward. Then on top we have the lone pair. Okay, let's try to see this on the simulation. Okay, again, let's try to. Again, that's tatlong hydrogen, then we have 1 lone pair. If you see this, okay, this is the shape of the molecule. Again, let's try to draw this. Here we have here nitrogen. Here we have isa ka lone pair. Then this one is on the plane of the paper. Then again, this one is coming forward. So again, we use the wedge line for that. So wedge, then hydrogen. Then this bond is going backward. So we use the broken line for this. Then again, this is the shape for NH3. Again, the shape for this is trigonal pyramidal. Trigonal pyramidal. So it's like a pyramid, yung shape ng molecule. Okay, that's the shape for NH3. Let's go back. Okay, the next molecule is SF6. The same thing. Let's start with the electron dot structure. That's sulfur in the center. Then 6 ka F. 1, 2, 3, 4, 5, 6. Again, F, it has 7 valence electrons. It needs one more. So it will form a single bond with this one. The same thing for this one. Single bond, single bond, single bond, single bond, single bond. Next, let's put the valence electrons here again. For F, that's 7 valence electrons. That's 7 dots. We have one here. Let's add some more. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Then 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And again, we can simplify this one. We can remove the valence electrons on the sides of these atoms over here. We can have this one as the simplified electron dot structure for SF6. Next, you count the number of electron groups. Again, let's draw the VSEPR model. Again, count the number of electron groups, the areas occupied by the electrons. So in this case, we have 1, 2, 3, 4, 5, 6. We have here 6 electron groups. Then do we have any lone pair here? On this case, walang lone pair, so 0 lone pair. Next, we look for the table. We have 6 electron groups with 0 lone pair. The shape is octahedral. So in this case, again, that's sulfur in the center. Then we have F here, then we have F coming forward, F going backward. Then again, another wedge here, forward, F. Then sa likod, that's F. Okay, let's visualize this in the simulator. Again, that's 6 atoms. Okay, that's 6 atoms. Let's draw this one. Okay, let's erase this one again. That's S. Then taas, that's F. Obos, that's F. Then this one again, this is coming forward. We use the wedge line for this. Then F. This is going backward. We use the broken line for this. F. Then this one, wedge. F. This one is going backward. That's another F atom.